Welcome to this video on mastering arithmetic sequences in algebra. Today, we'll explore how to represent and calculate sequences to help you prepare for your Kerala Class 10 SSLC exams. An arithmetic sequence is an arrangement of numbers following a definite rule. We use algebra and natural numbers as position indicators to describe them concisely. The term at a given position is denoted as x sub n. The general algebraic form of an arithmetic sequence is x sub n equals an plus b. Here, a represents the common difference, and b is the first term minus the common difference. When you have two terms at different positions, you can find the common difference by dividing the term difference by the position difference. This is a great shortcut to save time in the exam hall. A key property of arithmetic sequences is that the difference between any two terms is always a multiple of the common difference, proving that these differences are perfectly divisible by d. Calculating the sum of basic sequences is straightforward with standard formulas. For natural numbers, even numbers, and odd numbers, these formulas simplify your work. Interestingly, the sum of consecutive odd numbers starting from 1 is always a perfect square. The general sum formula is s sub n equals pn squared plus qn. A useful exam insight: the coefficient p is always half of the common difference. When you know the first and last terms of a sequence, you can use a simpler formula for the total sum, n over 2 multiplied by the sum of the first and last terms. If you are given the sum formula, you can reverse engineer the original sequence by finding the first term and the sum of the first two terms. A quick shortcut is that doubling the coefficient of n squared gives you the common difference. For sequences involving powers like perfect squares, there is a specialized sum formula involving 1/6 times n plus 1 times 2n plus 1. Use this cheat sheet to memorize core concepts. Always remember to verify your work by plugging n equals 1 into your formula to ensure it matches the first term. Finally, apply these techniques to practice problems. Calculating common differences in sums using these methods will prepare you thoroughly for your exam.